Hey, Geometry, Mr. Florio. Here's Unit 5, Lesson 9, volumes of cylinders and prisms. Um, the same but different. Here's two solids. We have a cylinder here and a rectangular prism. It's kind of like a cube, but instead of all the sides being the same, it's more rectangular. What some information would you need to calculate the volume of each solid? So I don't know if you can look up it quickly, but if you've ever seen the formula for volumes of cylinders and prisms, both of them actually have the same volume formula. You take the area of whatever the base is, I'm going to call it capital B, and you multiply it by the height to get the volume. So both of these, the volume is whatever the area of the base is times the height. Their bases are different though. The base here is a circle. And here the base is a rectangle. So there's a little bit of a difference here. The area of a circle is pi r squared. So the volume formula for this particular shape would be the area of the base, which is pi r squared, times the height. Here, the area of the base would be length times width. That's the area of the rectangle times the height. So what information would we need? Well, let's see. For the cylinder, we need the radius and the height. For the prism, we need all three: the length, the width, and the height. So this would be the height here, h. This would be the height here that we need either case. We would definitely need the width. So that would be that right there. And finally, the length would be here. So we need all three of those dimensions to find the volume. Here we just need the height and the radius. So the radius would be the radius. I didn't want to draw it up here to draw over the black writing already. So we would need just the radius and the height to find this volume, and the length, width, and height to find that volume. So what's the same and what's different about how we find the volume? Well, let's see. I would say for same, both use the formula base times height. What's different? They have different bases. Right, one's a circle, one's a square. Okay, so what's the same and what's different? Well, they both have the same formula, right? Base times height. But the base for the cylinder is a circle, so the base is pi r squared. The base for the rectangular prism is a rectangle, so the area of the base is length times width. So they're very similar. There's just a slight difference that they both have a different base. So in 4.2, here's two containers. All the measurements are in centimeters, okay? Suppose the prism contains, so the prism's the one on right here. Suppose the prism contains water that reaches a height of 1 centimeter. Let's try to draw that. Sure. So we're gonna put water in here, and then the height's gonna be 1 centimeter. So the whole height is 10. We want about a tenth of that. So we'll say that height right there is 1 centimeter. So that height right there is 1. So we're filling this up with water. All right, part A done. Now the water is going to be poured from the prism into the cylinder. What's the height of the water in the cylinder? So when I take this water here and kind of pour it into the cylinder, how high in the cylinder is that going to go up? Well, what I need to do is I need to take this volume and pull it and pour it in here. So I got to see how much volume is in here, and then maybe work backwards to find out what the height would be once I know what the volume is. So the volume of the prism part with a height of 1 is length times width times height. It's the area of the base times the height. Let me write that first. The base is just length times width, and we need to multiply that by the height. So the base is 4 pi times 9, and we need to multiply it by the height, which we know is going to be 1. So the base is 4 pi times 9, which is 36 pi. So the area of the base is 36 pi. 36 pi times 1 is still 36 pi. So that's how much volume is coming in. We could put that in a calculator if I want to get an approximation. That's about 113.1. Square centimeters. I'm going to leave it as 13 pi though. So I'm going to leave it like that. So if I were to take 36 pi cubic, not square, cubic centimeters and pour it into here, we want to find out what the height would be if I poured in 36 pi cubic centimeters. So I know the volume is 36 pi, so the volume of this shape is still base times height, but the base is a little bit different. The base is a circle, so it's pi r squared times the height. And I know the volume is 36 pi. I know the radius is 6. And I want to find out what the height is. We'll have an equation with just one variable to find. I'm just going to plug in and solve. So I'm going to put that much volume in, about 113.1 cubic centimeters. And that's the same thing as pi times the radius squared times the height. So again, the formula is area of the base times the height. Well, the area of the base is whatever 6 squared times pi is, which is 36. 6 times 6 is 36. And now just divide both sides by 36 pi to solve for h. The 36's divide out, the pi's divide out, those pi's divide out, and 36 divided by 36, that's going to divide out, and that's going to leave me with 1. So it turns out the height is actually going to be the same. And I guess what I'm noticing is that the area of this base is 36 pi. It was just 6 squared times r squared times pi, so 36. The area of this base was base length times width, which is 4 pi times 9. That was also 36 pi. So they both have the same base, so it makes sense that whatever the height is for this one, if the volume is the same, it's going to be the same height for that one. So what's the last part of this question? What is the height? Explain your reasoning. So what did we do? Using the volume formula, we found the volume of the prism to be 36 pi. Plugging that into the cylinder's volume equation, we solve for h. And one thing that's interesting here is they both have the same base area. They both had an area of 36 pi. All right, so let's just finish it up. Suppose the prism contained a water that reached a height of 3. So suppose this was now 3. If the water was poured into an empty cylinder, what would the height of the cylinder be? So what would that make the height here? And that's no longer going to be 36 pi. So let's find out. Based on our reasoning, I bet it's going to be the same thing as the height here. So if the height here was 1, then I think the height there is going to be, if the height here is 3 now, I think that's going to be 3. And let's just do the same process. So the volume of the prism is the area of the base times the height, which is the base is just length times width times height. And the length we still know is 4 pi. And the width is still 9. And the height is now 3. Again, the area of the base is still 4 pi times 9, which is 36 pi times 3, which is, I think, 108. Let me just double check that. Yep. So we get 108 pi is the volume of the prism. So plugging that into the volume of the cylinder, we said that was base times height, which is also pi r squared times height because the base is a circle now. So plugging in the 108 pi for the volume, that's got to be equal to the area of the base, which is pi r squared, times the height, which I think is going to be 3. 6 squared is 36. And we have 108 pi. So divide both sides by 36 pi. And the pi's cancel out. 108 divided by 36. Yep, that's still 3. So the height's 3. Anyways, the idea for this is if they have the same base and the same volume, then their height has to be the same. Because we're using the same formula, if the volume is the same volume in each figure and they both have the same base area, then it has to be the case that their heights also have to be the same. And the main thing here is just being able to calculate volumes. This is something that you've probably done before, but just seeing it again, it's going to come up a little bit more throughout the chapter, being able to calculate volume. And here's the formulas for cylinders and prisms.